Nobody watches these videos anyway, right?
Oh.
All right.
Yes, I do. I actually do.
Yeah.
It's just me. It's really just me.
All right. Anyway, so there's a quick pace of scientific advancement in the last third of the century. So in the last 30 years of the century, there's a quick pace of scientific breakthroughs. And so this enormously stimulates other inquiries and just it's a snowball effect, right? Once the ball starts rolling, it just begets more exploration of science and thinking and technology, and just more and more occur. So breakthroughs begin to occur in this time period. People now try to explain how things like blast furnaces or steam engines work theoretically. So like blast furnaces or steam engines have been around for decades, but they just know that it does what it wants to do. Now they're going to take the situation and try to use science to figure out why it does what it does, right? So they're going to try to start taking science and understand, like, how does the heat react and all those other things to make, the blast furnace work? Or how does the steam engine work? Exactly. So they're going to start trying to do theoretical discoveries and try to make those theoretical discoveries improve material, and make material improvements. So they're going to try to take theoretical discoveries and make improvements, material improvements. This is where you get the study of thermodynamics. It's Friday, I can't talk today. This is where they get the study of thermodynamics. Thermodynamics is a branch of physics built on Newton's laws of mechanics. So thermodynamics. Huh?
Oh, bars.
Yeah. You're welcome.
Say it again, but like with mechanics.
Thermodynamics is a branch of physics built on Newton's laws of mechanics.
Oh,
That's something in
I know. That investigated the relationship between heat and mechanical energy. So a lot of it's studying the relationship between heat and mechanical energy. And so obviously in a world still run by steam and coal, this is very beneficial. Because they're going to use all this research to study how mechanical energy and heat scientifically can be used to make improvements, right? So a branch of physics built on Newton's laws of mechanics that investigated the relationship between heat and mechanical energy. It represented a development in physics showing a practical development for human benefit. So it represents practical use of physics for human development or human improvements. Thermodynamics reveal that energy cannot be created or destroyed, but can be converted. So thermodynamics research indicates that energy cannot be created or destroyed. It can only be converted to something else. Oh, nice. These laws get applied to mechanical engineering, chemical processes, and more. So they're going to start applying these to mechanical engineering, making improvements in machinery, as well as steam power, those kind of things. It's going to be used for chemical processing, so on and so forth. All right, looking at the Second Industrial Revolution. So the first one was dominated by what country? Britain, with other players like Germany, France, and the United States kind of trailing, coming up from behind and kind of trying to catch up. But you have this second wave that hits. In America, this is our big one, right? So in America, when we hit this post-Civil War, this is where we have, where we thrive, and we actually surpassed Great Britain by the 19-teens.
Yeah.
The major difference between these two is that this is the era of heavy industry. So if there's one big distinguishing factor, this is the era of heavy industry, like massive factories of oil producing and steel producing, like you learned about last year.
This is where you get into rubber barons and real.
Right, big corporations, trust busting, all that stuff, right? So in this era, Europe underwent a dramatic expansion of manufacturing, transportation, and trade that becomes called the Second Industrial Revolution. So manufacturing, transportation, and trade become big in this time period. New innovations in manufacturing increase mass production. Mass production is a big defining feature of this time period. So like before with factories, a lot of it was machine done or handmade still. Now you're in a phase where pretty much everything is mass produced and in big time, big assembly line type stuff. So you're going to get a lot more mass production, a lot more assembly lines, and a much bigger scales now. where it's like massive factories you're working in or plants. So this new innovations are increasing with mass production. Steel becomes a major industry. Before it was iron, and you had steel, but no one knew how to like mass produce steel. So your boy from last year, if you remember, Bessemer, is going to figure out a way to mass produce steel and makes it more predominant. So so steel production becomes big in this time period, and steel becomes cheaper as a result. Electricity revolutionizes society. So electricity comes out 80s and 90s, and so that's going to lead to transportation improvements and household appliances and those kind of things, like the vacuum, you know, Zach, and a toaster, and a wash machine, stove. All right. You also get the creation of the internal combustion engine. This is a big deal. So, like you had the steam engine, now you have the big deal of the internal combustion engine. So this is going to lead to cars, right? Automobiles. So this is going to lead to vehicles being powered by gasoline or diesel. But so many things use like oil or petroleum now, which is better and easier than using coal. So and that's one of the reasons why we have not replaced gas engine cars yet, because no one's really found a solution for technology that you have such a cheap fuel source that can create such a big explosion or big energy explosion within a gas-powered engine, which is why we still use cars the way we do. So people who are out there want to use electricity for cars or peanut oil, whatever they want to use, right? It doesn't have the same impact or the same reaction exactly. And here's the thing, which I don't think most people realize. Okay, if everybody starts using electrical cars, right, then you're going to have to power those factories from somewhere, right? Which means electricity power plants are going to have to greatly increase their outputs. How do you think that's going to happen?
Renewable energy.
Yeah, it's either going to be nuclear or it's going to be coal, right? It's one of those two.
We have wind farms and solar panels.
But it's not going to have enough to produce enough power to power all these vehicles and
We
stuff.
can power the entire United States with solar panels within the state.
My point is we have to do a great expansion of these companies because they'll be like the amount of power that flows through a charger to go through a car and like the time it takes to charge is like dramatically more than what a house takes out in a day. Which means you're going to be paying through it with your bills and stuff, but it's going to take those companies. If everybody does that, those factories and plants have to greatly expand their capacity every day. But my point is, if you're trying to eliminate things like pollution and everything else, it's not necessarily doing that. So that's my point. Like, it's either over here or it's over here. So like, where do you want your pollution, basically, right?
Or is this going to be a short-term effect to kind of help that problem?
What?
Is it going to help the problem in the long run?
That's a question they're trying to answer. So I don't know.
I mean, like, listen.
Here's the problem: if gas still remains as cheap as it is, and people still use a car because it's just that much cheaper, it's gonna be hard to.
It's also cheap because we live like right next to it. Like people in California gotta pay like almost $5 a gallon.
Well, that's California. That's why we don't live in California, right?
What's it? That's the other problem.
Exactly. Yeah, it's not our problem. All right. Anyway, mechanization and factory systems. Mechanization and factory systems. Expansion of factories increase the demand for the machines that create a product. So expansion of factories increase the demand for machines that create the products. Which makes sense, right? You need to make newer and better versions of the machines or more machines to make your process faster.
Wait, say the name.
Yeah, so expansion of factories increase the demand for the machines that created the products. They needed to be standard in size, shape, and function, and easily replaced. Like you need interchangeable parts, right? So they needed to be standard in size, shape, and function, and easily replaced. So they need to be standard in size, shape, and function, and to be easily replaced. This industrial revolution phase saw the rise in manufacturing of machine tools that shape and build other machines. So that's a distinction of this era. That this phase saw the rise of manufacturing of machine tools that would shape and build other machines. So you're making machines to make machines. Whoa. Yeah. All right, so looking at Manchester, England. Manchester, England. During the second phase of the IR, Manchester, England becomes one of the world's most industrialized cities. So Manchester, England becomes one of the world's most industrialized cities during this phase. So Manchester started off as just like kind of like a more rural town. It had some factory stuff, but it's going to become this major heavy machinery factory center, which is why it's such a big city in England today. So it becomes one of the world's most industrialized city and a city for manufacture of machines used in production of textiles and other consumer goods. So it becomes a center for the manufacture of machines used in production of textiles and other consumer goods. So Manchester becomes a center of manufacture of machines used in the production of textiles and other consumer goods. They also built some deep canals to get to Manchester. So they also built some very deep canals so they could have barges go up and down out of Manchester. Not horse drawn. These are, steam power, maybe even gas power by now.
They didn't want to use railroads?
That's a good question. I'm not sure why I guess they figured they could ship out more freight with canals than they could on railroads. So I'm not really sure why they chose that over railroads. So they constructed deep canals in the late 1800s to bring cargo ships in. I just assume because you can put a whole lot more on a barge than you can on a train. So and it's less energy too, so it makes sense. But it's just a lot more expensive to build than a railroad. In 1898, they created the world's first industrial park, which was an area designed only for manufacturing. So in 1898, they designed the world's first industrial park. What's that?
It's like the episode of SpongeBob.
Yeah.
Like it's all the
I don't watch
It
them
was
like
like
that.
the opposite of actual.
You don't watch SpongeBob?
Exactly. It's the opposite of actual park. It's all fun machinery and metal buildings and stuff, right? Ford Motors actually opened up a company in Manchester, England in 1911. So it's also internationally known as being an industrial center. So like other companies come to Manchester, even American company, Ford Motor Companies come to Manchester, open a factory there too. So this led to this idea of Manchester capitalism. This led to the idea of Manchester capitalism. The idea that free trade could raise all people's standard of living. This Manchester capitalism is the idea that free trade could raise everybody's standard of living. Meaning that these industrialists are pushing for more and more free trade because that means you get companies that now expand across the globe making products hopefully cheaper, which would make everybody's lives easier. The cheaper your product, the better, right?